All right, so day 2 of section 7.5 is properties of kites. We did trapezoids yesterday. So a kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides that are not congruent. All right, so the opposite sides are not congruent. So using that, the theorem 7.18 is the kite diagonals theorem, and it states if a quadrilateral is a kite, then its diagonals are perpendicular. So according to the diagram we just have there, is if quadrilateral ABCD is a kite, then we know that AC, you can't see the A there, but AC will be perpendicular to BD. Of course, we're talking about the line segments. And then the opposite, kite opposite angles theorem, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So if quadrilateral ABCD is a kite and BC, line segment BC is congruent to line segment BA, then angle A is congruent to angle C. And we know since it's not exactly one, we know that angle B cannot be congruent to angle D. All right, so example 5, find the measure of angle C in the kite shown. All right, so because angle B is not congruent to angle D, then we know that angle A and angle C must be congruent. All right, so if we know that they must be congruent, then we know that the measure of angle A plus the measure of angle C for some reason it doesn't want to make my M right there. There we go. Plus what? The measure of angle 80, which is the measure of angle B is 80 degrees and D is 50 degrees. And what does the sum of the angles of a quadrilateral always equal? 360 degrees. So we know that the measure of angle A plus the measure of angle C plus 130 is equal to 360. We know that the measure of angle A plus the measure of angle C then is equal to 230. And we know that the measure of angle A is the same as the measure of angle C. So that would mean we could just say that the measure of angle C plus the measure of angle C, or we can say that 2 times the measure of angle C is equal to 230. So again, if we divide that by 2, we'll find that the measure of angle C is equal to 115 degrees. All right, so the chart that is shown below then shows all of the quadrilaterals studied in this chapter. All right, each shape has the properties of the shape linked above it. So for example, a rectangle, which is right there, right, has the properties of what's above it, a parallelogram, and a quadrilateral. So a rectangle has the properties of a parallelogram and a quadrilateral. Okay. So we kind of need to know that for your last couple problems in the homework too. But here it says example 6. What is the most specific name for the quadrilateral JKLM? So we're just going to write a lot of stuff that we know here, ladies and gentlemen. I can say from, oops, I better quit using that thing. So from the diagram, what can you tell me? You can tell me that that line and that line are parallel. So you can tell me that JM line segment is parallel to line segment KL. And you can tell me that those two lines are congruent and those two lines are JK. Is equal to ML. Since they're congruent, you know that their measures are equal. That's what you can tell me. You do not know whether or not the parallel sides are congruent, or if the congruent sides are parallel. You don't know that because they're not marked that way. So if that's the case, then you can't call it a parallelogram, which means it also can't be so I'm just going to show you up here. We're saying it can't be a parallelogram. So we know it also can't be the things that are below it because we just said it can't be a parallelogram. Remember, it can be quadrilateral because it could go up above, but it can't take the characteristics of the ones below it. All right, so we know it also can't be a rhombus, a rectangle, or a square. Okay. So we're at there now. It could be, do we think it could be a trapezoid? Could it be a kite? Could be a quadrilateral. Those are our last three choices we have, right? And if it's trapezoid, it could be an isosceles trapezoid. So let's see, what can we say about that? So to be a trapezoid, let's start with that one. We would need to know the parallel lines are not congruent because the bases have to be on a trapezoid because the bases have to be different lengths. Okay, and let's put that in parentheses. And it can't be a kite, so it can't be a trapezoid, and it can't be a kite because remember with a kite, the adjacent sides have to be congruent, and in this case we have a pair of opposite sides congruent. Now I'm pretty sure you won't have to write all of this down with yours, but I did try to make one where we eliminated everything except for, therefore, the most specific name for our quadrilateral JKLM is a quadrilateral. All right. So I gave you one that's, the other ones that you'll have won't be as difficult as this. It'll be interesting to see what you have to do if you have to drag and drop. I'll be looking at that too. Thanks, people. See you tomorrow.